So what you can see here is the quiz and the idea about the projector. I mean, you know, my mind is so much to projectors, man. The idea about the vectors and the vectors resolution. And the first one, you are told find the resultant of the forces in the diagram given, in this diagram given. Then we have A and B. We said there are two things. Yeah? If the vector given has a right angle is at 90 degrees, that's easier. But when it is not 90 degrees, it's like a scalene triangle. That one takes you directly to the idea. You need to use the scale diagrams, and that's the aim of our lesson today. The first thing we said last time you should worry about is the scale. So that's the first thing to worry about. Now, the scale. But before I go to the scale, I first want to make sure I can be able to, that is, draw a sketch about what is my final product here. That's the question. What will be the final product I'm going to have here? So then, if I can do the final product I'm going to have here, I'm going to translate this line in the opposite direction. So it's gonna be here. This will be this down vector here of 15 newtons. And then I'm going to translate this one to this other side. Okay. So then this will be my 10 newtons on this side. So I've crossed that diagram. And my resultant vector is going to be in between the two. So this is what the examiner is looking for. He's asking for the resultant vector that should be in between. So I've been able to make my parallelogram, and therefore that's why we get the word parallelogram method. Okay, method of vector resolution. So then I'm going to use my ruler to help me do this. I'll put it here. Then I'm going to use my protractor, of course, also to do this work. And also I'm going to use my compass to do this. So those are my tools, very important, that I'm going to use to do this work. So from here, I have already have a sketch. That was my first point. I already have a sketch. I have a mental picture of where I'm going. It's just like an engineer or an architecture. Before you construct a house, you need a blueprint. You need a map to help you know where you're going. And we have our map is here. So the next thing we need is a scale. And the rule for the scale should be, it should not be so small, it should not be very big. It should be just the right one. Not so small, not big, but the right one, depending on where you are drawing. And I suppose most of us will also be using like an A4, like the book I have. So when I look at 15 newtons, and then I imagine I'm going to draw like 15 centimeters, my 15 centimeters, again, it will be my ruler here, which is absurd because this is quite big. That will be a giant vector diagram on my piece of book. So I don't want to do that. But I can reduce it to somewhere halfway, such that if this was 15, I can have 7.5. That's fine. I don't have a problem with that one. Or even I can say, since I can see 15 and the rest are 10, 15, so 5 is a common factor, I may think of 5. But if I think of 5, I'm going to draw 3 centimeters here. That would be so small, but not bad for people who like microscopic things. But let me choose 1 centimeter will represent, should I say 2 newtons? 1 centimeter represents 2 newtons. In other words, my scale, I'm defining it as 1:2. That's my scale. 1 centimeter representing 2 newtons. So if 1 centimeter will be representing, that is 2 newtons, what about my 15 newtons? Will be represented by what? So then I have my 15 newtons will be represented by
7.5.
Yeah,
7.5.
7.5, let's see. So if 1 centimeter represents 2 newtons, what about 15 newtons will be represented by x? So if I can then have the cross multiply, I'm going to have 2 times x is 2x is equals to 15 times 1 is 15. So divide by 2 divided by 2. So then I have x is equal to 7.5 newtons. So I'm going to have this to be 7.5 newtons. I have to be careful with the scale again. So then that means my 10 newtons, in other words, I'm dividing by 2. This was 15 divided by 2. So for 10 newtons, how many centimeters do I need?
5.
Yes, I need 5. Okay, 5 centimeters. Thank you. So then I'll come to my sketch. I'll come to my, oh, this was not 30 newtons. This was the 30 degrees, guys. I've written the angle like 30 newtons. It should be 30 degrees. So then I'll come and start doing my scale drawing right away. So remember the blueprint is here. So I'm going to start with this line first. Okay, this line. So then let me draw the first line, the baseline of my blueprint. I want to capture my blueprint there. So let me, so that you can see I'm following the two of them. So the first thing, of course, I don't have to worry so much because I'm just going to have a neat straight line, just straight away, a straight line. And then I'm going to mark the starting point, Then I need, for 15 newtons, I need 7.5 centimeters. So I'm going to open my compass here and then measure 15 centimeters, 7.5 centimeters. So that's 7.5. So then I'm going to transfer the 7.5 here. Okay, 7.5 is here. I've made a mark. So this is my 15 newtons. I don't want to write 7.5, but already I have that one. The next thing I'm going to do is that I need this angle. I need the angle of 30. There should be an angle of that here. So I'm going to take my protractor and then turn it such that the center of my protractor is also coinciding exactly with my starting mark here on the line. So I'll press it and make sure exactly that even my baseline is also aligning with the baseline of the protractor. So then I'll move from 0, not from 180 of course, but from 0 all the way to 30. At 30, I'm going to put a mark there. Okay, a mark at 30. So then I'll pick my ruler and then join this mark I've made with a starting point, the center point there, and then I can see I've make the line as big as possible because you want to have the exact point there. So the other thing is that from my blueprint is that I had these 10 newtons. The 10 newtons are here, the 10 newtons. So then I should make sure 10 newtons, we said here they should be represented by 5 centimeters. So again, I'll come with my ruler. Of course, most of us, we just come in, on our ruler and we press like this, okay? And then we mark where 5 is. That's one method to do it. I can press my ruler reading from the first point here where my 5 is. That's one. Or I can pick my compass and then press from 0 all the way to 5, all the way to where 5 is. So I'll move it up till where 5 is. You can see I'm pointing at 5. Okay. Then I'll transfer that by my compass to be exactly at that point. So I've made again my 10 newtons is here. Okay. So then from there, I'm going now to construct my parallelogram. This is 30 degrees. So I should make sure again, according to the parallelogram, there's this other line according to my map. There's this other line that should be here, okay? There should be another line here. It is just opposite to this vector, should be opposite. And there's something we said. The supplementary angles in a parallelogram add up to 180. Do we call this and this supplementary, guys? Of course, we know if we talk about this angle and this other angle here, those ones, we call them alternate and they should be equal. So this also should be 30 degrees. Should be 30 degrees. Are we together up to that point? So this is 30. just like this is 30, this one here is also supplementary with this. So these angles should be 180, so this should be 150, or rather angles on a straight line here, 30 and 150 should be 180. So then I will come to then my point here, and then construct either the alternate angle, which is 30 degrees, or I construct the supplementary one, which is 150 degrees. So I'll move from again 0 all the way up to where my 150 is. 150 is at this point here. Then I'll pick my ruler, join on the mark, that is the mark on my line here, and then join with again my mark here, and then make a straight line. Okay, a neat straight line. So the next thing I remember was that this was 5 centimeters. Okay, it should be the same as this other side. We call them congruent vectors. I hope my compass is still at 5. Exactly, it's also still at 5. So I'll mark my 5 points there. Okay. So then from this point, I don't have to worry much. I'll just join this point with this other point to make the corresponding vector at the bottom. So then I'll move my ruler to join this mark and join this other mark here. So here we go. So then I have these vectors, opposite vectors, and this other one. So I have my nice and neat parallelogram. So the final thing I'm going to do to get the what we call the resultant vector, we said, should be this diagonal in the same direction as the other two forces. So this center diagonal. So I'm going to come to my diagram here and drop my diagonal. Then here is my diagonal. So this is my resultant force. So I'm through with drawing to scale, and the last thing I need to do is then convert to get the actual resultant force from this. So if I measure with my protractor, I can either measure with my protractor, I'm getting something like 12, or if I want to be very precise, I'm going to use another tool. I don't know whether you've ever used this tool or it's just been lying there with you. You know this tool, guys?
Compass.
A compass.
Divider.
A divider. Okay, we call it, it should be the divider. So this is now the purpose of a divider. It is now for this particular purpose. You point at the starting point, at the ending point directly. Okay, so this is the length of the vector. Then I translate it by checking from my ruler. I can see it's exactly 12.1. Okay, I don't know whether you're able to read for me. What are you seeing there, guys? I'm seeing 12.1. What are you seeing?
Yeah, 12.1.
Okay, so then it will be 12.1. My resultant vector here is 12.1 centimeters. So what I'm going to do is to use now the scale. I'll say I had used a scale of 1 centimeter represents that is 2 newtons. So then I need to ask myself, what about 12.1 centimeter represents what? Of course, I can write in terms of that representing, or I can do mathematically, like if 1 centimeter is equals to 2 newtons, what about 12.1 centimeters is equals to x? Then you cross multiply. If you cross multiply, you're going to get your x is equals to 12.1 times 2, and that should be 2.4.2 newtons. That's my resultant force.